all intercommunication styles for NestJS Microservices. Hey guys, welcome back to Sakura channel, and this is the episode 2 of our NestJS Microservices course. In this video, we are going to talk about all communication styles for microservices in NestJS. So with that extra explanation, let's get into it. In the previous episode, we have turned this monolith application into this microservices architecture. And also we have set up the TCP transport layer between the API gateway and our microservices. But the TCP is not the only way that microservices can communicate with each other. Actually, there are two primary ways that microservices can communicate with each other. Synchronous communication, which is also known as request response, and also asynchronous communication, also known as event-based communication. So first now let's talk about synchronous communication. In synchronous communication, services make direct call to each other and wait for responses. In other words, this is when a microservice make a direct request to another service and wait for its response. An example scenario here is like when a user places an order, the order service needs to synchronously communicate with the user service to verify the user's balance and then call the payment service to process the payment before confirming the order. So here we need to use synchronous communication because we need to wait for the response from the microservice that we are calling. In NestJS, we can implement this type of communication style with normal HTTP requests like REST API or GraphQL, TCP transport, and gRPC. The other type of communication in microservices is asynchronous communication, which is also known as event-driven communication. This is when services send messages or events to other services without waiting for an immediate response. Other services listen for these events, and then as soon as an event comes, they catch them and process the event. An example scenario could be like when a payment is successful, the payment service emits a payment success event, and the user service listens for this event and updates the user transaction history. In NestJS, we can implement asynchronous communications via Redis PubSub or message brokers like Kafka, RabbitMQ, or NATS. So now let's take a look at the pros and cons of each type of these communication style. The advantage of synchronous communication is that they are simple and easy to debug, but services in this type of communication are tightly coupled and we can have potential bottlenecks. The pros of asynchronous communication is that the services are loosely coupled, scalable, and fault tolerant. On the other hand, the cons of this type of communication is that they require more complex setup and need a message broker. So when to use what? For real-time requests like fetching products, we should use synchronous communication. For background tasks like email notification, we should use asynchronous communication. For the payments and transactions that requires immediate response, we should use synchronous communication. And for order status updates that does not require an immediate response, we should use asynchronous communication. Alright, now let's talk about all transport layers and how they are used in NestJS microservices. Well, a transport layer is a mechanism that allows microservices to connect with each other. And NestJS supports several transport layers. The first one is TCP, which stands for Transmission Control Protocol. TCP is a reliable and connection-oriented transport protocol that ensures the ordered delivery of data. So what is the use case of TCP? It's ideal for service-to-service communication where reliability is a concern. Is it synchronous or asynchronous? Well, it can be used for both, but we use TCP directly for synchronous communication between our microservices, although it is the underlying protocol by Redis and NATS, which are used by asynchronous communications. This transport is good for high performance and low latency communications. The next transport is gRPC, which is a high performance open source RPC or remote procedure call framework. It's based on HTTP2 and is useful when you need efficient and fast communication between your microservices. So what is the use case of gRPC? You can use gRPC when you need strong typing and efficient and fast communication. Typically, it is synchronous for direct requests, and the performance is very efficient, especially for large-scale systems. We're going to talk about it in detail and how to implement gRPC communication between our microservices in the upcoming episodes of this course. The next transport is Redis PubSub. Redis is commonly used for asynchronous communication, and it uses publish-subscribe pattern where services publish events like payment success and other services subscribe to those events. This is best for decoupled and event-driven communication. It's asynchronous and also high performance for real-time communication. We also talk about it in detail and how we can use it in our microservice communication in the upcoming episode. Next, we have NATS, which is a lightweight messaging system. It's asynchronous messaging system with support pops-up, request reply, and stream processing. An example of using this transport is when a service emits events to a NATS server and other services subscribe to those events. When we need scalable, high-performance communication for many services, we can use NATS for communication between our microservices. We also have a detailed episode in this course for this type of communications. Next, we have Kafka. Apache Kafka is a distributed event streaming platform used for asynchronous communication between microservices. In Kafka, we have three main elements. Producer, which is a microservice that publishes messages or events to a Kafka topic. In Kafka, topic acts as a channel that producers write data into it and consumers read data from that. The next element is broker, which actually stores and manages messages in topics. And third element is consumer, which is a microservice that subscribes to a topic and processes incoming messages asynchronously. So when to use Kafka in our microservices communication? For handling large-scale and real-time data streams and processing events, we can use Kafka for communication between our microservices. We will have an episode for configuring Kafka and using it in our microservices communication in NestJS. And finally, we have RabbitMQ, which is an asynchronous messaging system that uses AMQP protocol. In this type of communication, a service sends a message to RabbitMQ exchange and other services consume messages from a queue. For reliable messaging in event-driven system, we can use RabbitMQ. So these are the communication style that we can use in NestJS Microservices communication. Keep in mind that we can use multiple of these type of communication for each service. I'm going to show you how you can do that in this course. As I said, we will have a separate and detailed episode for each type of these communication style in this course. So make sure to subscribe to the channel to get informed about the upcoming section. Alright, stay tuned for the next episode. Don't forget to like this video. Have a nice time and bye-bye.